Hello friends. So my name is Deepak Thapar, a data and IT expert. So today in data science, I would be really trying to explain uh, linear regressions in a most simplified way. So that's one of the very key model in data science along with various other model. So let's just not wasting your too much time on it. However, it's very complex things to understand, but here I would be explaining in a very simplified way that you would be absolutely clear conceptually what the linear regression is. Okay, so let's start with a scenario. So the scenario is the T20 match is happening between India and England, and 9 overs have been played so far, and there is a scoreboard. So if you really see the scoreboard, how many overs? So that first over, uh, that start was very slow. The 3 runs were made. In second over, there was no run was made, and that overall score was 3 still after second over. And then suddenly the score got 12 runs after third over. And after fourth over, again just 2 runs were made, and the score came around out 14 runs. And then fifth over, the score got 17 runs, and the sixth over, then suddenly his score got 24 runs. Another 7 runs or so have been made. Seventh over, then suddenly I think there's Yuvraj Singh, and he probably had hit 4 sixes in a over, and then the overall score got to 48 runs after seventh over. So the 24 runs in seventh over, and that overall score is 48 runs. Okay, now that eighth over, again just a 1 run was made, and 49 was the score, and after ninth over the score got to 57 run. So if you really see, there the two variables are there. One is that uh, x variable, which we are calling the overs, and then second variables is runs, how many runs are being made. And if you really see, there is a bit of a relationship, because it's very simple data. We can understand there is a relationship. The relationship is that as many overs are being there, the runs are increasing. So that if there would be as many overs would be there, runs are dependent on to that number of overs. So that overall scores is basically is going in a one directions along with the overs. Now, so that is a way we can say the runs are dependent on overs. So that is a independent variable x, and that is a dependent variable y. Okay, so if you really see, that's the way it is increasing. Now we try to plot a chart in Excel itself. So if you really go in Excel, and if I go insert and I try to use this chart, yeah, it looks good. Let me use this one. I select the data. I select this two vectors out there, and yes. So you can see uh, a graph is plotted, and if you really see, this dots are basically, so that's, if you really see, that x-axis is number of runs, and y-axis, if you really see, these are that, sorry, y-axis are the number of runs, and x-axis is number of overs. So that as that over is increasing, that runs are going high. So that is a 3 run. So there's a 3 run on a first over. Second over, again there is only 3 runs, no increase is there in runs. Then run go 12. So this is a 12. If you really see, this is, so these are the intersections. So the points are being plotted between that x and y intersections, and based on to this every point, and this is a way the graph is going. However, this is a if you really see, that is increasing in a is going in a one direction. However, there is a random because you can't really go absolutely straight line, and it it is going little bit here and there, but it's going in increasingly in a one direction if you really see. So that is a very good example of linear regressions. Now, what we are trying to achieve out here. So if I just probably try to taken a screenshot of it, I taken a snipping tool, and I'm trying to taken a, let me take a bit of a screenshot so that we can do a bit of a play around on it. Okay, so so that's I've just taken a screenshot of it. Now what I'm trying to do, so if you really see, I'm trying, if you really need to see, if you have to predict what would be the runs after 15th over, or what would be the runs after 20 over, because that only the 9th overs have been played, so that you have to predict. So you can predict if you draw a straight line which is very close to, which is very much aligned with these dots, you probably can reach somewhere like that. If you really see that, one of the best line we try to draw, yeah, I'm just drawing with my hand, so it's going here and there, but it should be a straight line. And probably this is a point, probably I can predict what would be the score after maybe a 14th over, and this would be a probably score would be more than 100 if you really see this chart. Okay, so this is the score, so you can predict is a going, but this line, if you now this is because very simple, we are just doing very judgmentally, we are trying to draw a straight line, but that whether this straight line is a correct line or not, if it is going in a right direction or not. Okay, so that this is a linear line which we need to draw uh, using a linear regression. And the concept of the linear regression is that the line should be as closest to most of the dots. So the average distance from the each dots and overall that all the dots, that average distance of the line should be minimum. That would be the best line. Okay. So now there is a sort of a formula is there which we use normally for linear regression. So that's if you really see, we have this is a x variable, this is a y variable, and if you really see the formula, if you that's I have to do, this line is my L variable. So this x y, which is putting my dots, and this line is probably I'm calling is my L variable. So that if you really see that I have to get the dots for the line, so it would be Li is equal to, I just explain you, excuse my handwriting, it's because I'm using some sort of pad. Okay, so Li is equal to Mxi plus C. So that is a, I'm trying to use that each dot which I need to get onto to draw this line, straight line, that is a first, second, third, fourth. So that's, I'm just trying to use that sort of formula, which I say Li is equal to Mxi plus C. So that I'll explain you out there. Now the bigger problem is that we know the value of x, that we know, okay, but we don't know M, we don't know C. What is M? What is C? What are the value of M? What is the value of C? If we don't know these two values, that means we can't get the value of my L point. Okay. Now if you really see, I'm just trying to explain what this M and C are, that because once you have to draw the lines, so there the two things are there. What would be the slope of line, that how much line is tilted toward that x-axis, how much is the tilted out there. Okay, and C is that where the line is starting, where that's intersecting with my y. So if this line, if you really see, if I just judgmental line again, sorry, it would be hitting somewhere around at 9 and minus because this is a 0, y at 10, this is 0, and that would be probably a minus 10 or minus 11. So that would be starting from minus 10 of the y intersections, and it would be having a some slope, whatever that slope is, and it would be then going in a one direction, and it would be that my straight line. So these are the two values is going to define this, how this line is going out there. Okay, so that M and C, this is the two values I need to find so that I can get the value of my L. Okay, now that there is another formula to get the value of M. Okay, so value of M, there is a formula is there. So M is equal to, if I really see, this is a sigma, there's a summations of X, I will explain that, minus, this is mean of X, and Y minus mean of Y divided by another summations. I'll explain that, no worries. X I minus mean of X, this is a mean of X, and square of it. Okay, and this is the value is starting from I to N, I to N. Okay, so that is a summation. So that's what I am trying to do, that this is a mean. So these are, if you really see, this is my X value. So this is a, if I just say X1, X2, X3, X4, X7, X7, X8, so that's going till 9. Okay, this is my Y value, Y1, Y2, Y3, Y4, Y6, it is again going till Y9. Okay, so this is, so I'm going to use, and then there is a minimum, mean of X is somewhere, if I just say total it up and take an average out of it, then it becomes my mean of X, and this is the mean of Y. I total them up and again take an average of it, and it becomes my uh, mean of Y. Okay, so what I'm trying to do, that every single X value minus, I'm subtracting the mean, and every single Y value I'm subtracting the mean, and I'm then totaling them. For that every single value I'm doing 9 times. So I'm 9 times I'm doing this, and I'm totaling this all that 9 values out there, and then dividing it again. I'm taking out that from my X value, I'm to subtracting the mean each X value. So I'm squaring that, I'm taking a square of that, and then summing all these 9 different value which are coming. I'm taking a sum of that, and I'm dividing, then is bringing that value of M. Okay, uh, now this is the way we will get the value of M. Now you would be still getting confused. So let's take that how we will do that. So we'll break it out. So that first say, first that to, for this formula what we need first of all the mean of X. Okay, so we need a mean of X, and we need a mean of Y, mean of Y. Okay, so we'll first focus on to these two value. Okay, so let's focus on these two value, mean of X and mean of Y. So I'll take a mean of X. So let me do what I do, that I take a sum of all the value. Okay, right, so that it is coming 45. I have summed it up, and because these are the 9 values, to take a mean I dividing it 45 by 9. So this is becoming my mean of X. So with mean of X, so this is 5 is my mean of X. Okay, So this is the middle value, which is a simple. Okay, and now I am doing the same things for my y. I take a mean of y. So first I sum them up. I taking a total of all the values. Then I am dividing the total value by number of values. So the number of values are 9. So it is coming 25.22. So this is the mean of y, which is a very simple thing. So we got the mean of x, we got the mean of y. We got two values. Okay, I just okay mark them in red so it's easy to understand. Mean of x, mean of y. Okay, so now we got the mean of x and mean of y. So that means we got this value, sorry, this value, we got this value. Okay, we got mean of x, mean of y. Now how we will get, now we'll break this formula into multiple things. So let us do that. We need to find x, every x minus mean of x. Okay, so let's do that. So what we do that, every x minus mean of x. So what I do, the x minus m means I'm taking or maybe a mean of x. Okay, so xi minus mean of x. Okay, or so what I do, this is my x, this is my x. So first time my value is x is 1. So this is my x minus, and mean of x is my 5. If you really see, this is my mean of x. Okay, so you see the formula. It is saying that my first value of x and subtracting by mean of x. What I do that, I have to subtract all value with the mean of x. I what I do that, I hard code it so that when I copy the formula, that won't change. If you know the Excel and you're familiar with the Excel, you can see that when you use this dollar sign, so that when you copy the formula down, all the other cells will move. So like I'm copying it, the formula down here. So now this is doing from my A3, which is a 2, A3, this is A3 minus again mean of x. So again it is going the same value, is doing this A14. So A3 minus A14. Now if I'm copying again, it is doing A4 minus A14, A4 A5 minus A14, and I copy it for all the value. Okay, so that every single value is mean of y is subtracted from that every single value. Okay, now this has got my gut x minus mean, and I probably what I do that, I sum this up all the value. Let's not sum it up because it's not important right now. Now I do the same thing for y minus. So now I got these things. If you really see, let us use the different color. So I got this. Okay, now I need to find this. Okay, to find this, I'm using the same things, but I'm trying to do with the y. So what I do this. This is my value of y, first value of y, minus mean of y. Mean of y is 25.22. This is mean of y. Again, what I do that, I use the dollar sign so that when I copy the formula down, my mean value will not change. It will remain same. And my y, every single value will change. So the B3 minus B14, B4, and I continue doing that. Okay, and this is y minus mean of y. Okay, now you got x minus mean of x, y minus mean of y, which is simple things. So I got this both the two values. Okay. Okay. Now what I do that, and obviously I got this values as well, this value as well. Now what I do that, I make it, this is a numerator, so that upper value is, let's call it as a numerator, sorry, it's always numerator, and denominator. Okay, so let's me do a numerate my upper value, okay, which is multiplication of x minus mean of x, y minus mean of y. So I'm going to, what I do, I'm going to multiply this, I'm doing this two multiplication, this multiplication, this, okay, and I do for all the element. I did it for this. So this has become my numerator, okay. And but what we have to do, that we have to sum all the numerator. So we have to sum them up. So we have to sum. So this is a summation. So to the summation, what I do, I say sum all element of numerator, I sum them up. Okay, so it is coming 436, and I call it what? Numerator. Okay, 436. So let's make it red again. This is now the same things I would do for denominator. Denominator. The denominator, what is that? Simple things. Denominator is that value of x, the square of x. So x minus mean of x. So this is x minus mean of x and the square of it. So let me square. So square means I take value of x minus mean of x, and again I multiply with the same value. So that is a square. Okay. So I'm multiplying them with that itself. So that means it becomes a square. Now I'm copying, I'm doing it for all the elements. So I copied the formula. So it is doing for all the element. Again what I do, I'm taking the sum of that. So what is that? I'm summing all this value. I use the formula sum of f2 minus f3. So this is my denominator. Okay. Now what is that actual formula? Formula is the numerator divided by denominator. So value of m is what? Numerator divided by denominator. Okay, that way. Okay, let's do this. So it's coming. So this is value of m. So value of m is what? This. So this numerator divided by denominator. So this has become my value of m. So what I do, that rather I do, don't call this as an m, sorry. Let's delete this. I write here value of m is equal to numerator divided by denominator. Numerator divided by 7.22. So this is my m. Okay, this is my this is my mean of x, this is my mean of y. So I've got the value of m. So now finally what I've got? I got the value of m. I got that. Okay, simple. Now what I need to find the value of L1. So now I need the value of C. So now I know M, I know X, but I don't know the value of C. Okay. So now that we need to find the value of C. So the formula for the C would be mean of Y. Now why this is that way, I'll explain. M mean of X. Okay. Now what is going to happen when you drawn this line out there? Okay. So you know that your mean of Y X is what? Your mean of X is 5. Okay. And mean of Y is what? If you really see what was my mean of Y, mean of Y was 25.22. So 25.22 will come somewhere here, and this is going out there, and this is, sorry, it is not very straight line, it's going somewhere here. This is the intersection of my mean of X and intersection of my mean of Y. Okay. Now whatever line we will go, L1 will go, it will definitely will pass through this dot. Because whatever the line previously I drawn, that if you really see the red one, because we judgmentally we drawn it, we didn't draw it correctly. Ideally it should have crossed this dot. This means cross this mean of X or mean of Y intersection. Okay. So what we are trying to see, and this is called is a C intersection. Okay. That is the way it brings that intersection for the C. So what I am trying to see, do that mean of Y minus M, we now don't know the value of M, and X. So simple is that what is my value of C would be. So my mean of Y is 25.22 minus my value of M is 7.26 multiplied by my mean of X is 5. So means multiplied by 5. I don't know whether I write it again. 25.22 minus 7.26 multiplied by 5. Okay. So this is the mean of Y minus mean of X multiplied by 5, and that whatever the value would come, that would be my value of C. So let's do that calculation in Excel itself. So that mean of, so value of C, value of C is, as I say, mean of Y, this is 25.22 minus value of M multiplied by mean of X. So it is coming 1.11, and as I say, C is the intersection where it is be crossing my line, so that this line should be crossing. So that is a minus 1, so it is should be going somewhere down from here. So that line would go somewhere down from here. Okay, so it would be crossing from here. So these are the value would be deciding. So now I know pretty much all the value, so that I know value of M, I know value of C, I know mean of X, I know mean of Y. Okay, and now the formula what I need to use. So now this is, if you really see, I know pretty much every value. Okay, now I can find that all the point of Li. So how it will get, if I just say, so L, this is my vector L. So now I had the vector X, I got the vector Y, now I'll get that vector L which I need, and it is a simple things. Formula is what? Mean of Mx. So M is this, sorry, I just try to write the formula. So this is M multiplied by X, X1, sorry, this would be not x1, sorry, my1, sorry, because I need to get this line, my my. So this is not x1. I need a, sorry, this was supposed to be, because uh, sorry, no, sorry, x1, right? This is fine. So this is my x1 plus c, and plus c, c is that value of this. Okay. So if I just say same, I just take the same value, m multiplied by x plus value of c. Okay. So that is the formula, m x plus c. Okay. Now what I'm trying to do, that I'm just trying to use the dollar sign so that my m and c value remains same. So I just use the dollar sign. This value of c or value of m remains same, and x value is a variable. So whenever I copy the formula, this value would be changing. So if I just say the formula is, when I copied it, now it become a3, rest everything is the same. Now I try to copy it all together from here to here. Okay. Now this is, I've got that L vector. Okay, vector L. So all the value of L, L1, L2, L3, L5, L6. So this is what I needed, Li. So that all that L values I've got. Okay. Now what I try to do, I use the same chart and I go in a select data. So I had selected this data, X variable and Y variable. I add another variable to that. This is a third variable. So I got Y variable, L variable, and I got X is my horizontal line, X variable. So I got all the three variables. So previously we were using only two variables. Now I'm using three variables. Okay. Now if I try to do that, if you really see, now you can see that yellow dots coming and they're looking very straight. And while the blue are there, that blue one was there because they were that actual runs. They're going here and there, but that yellow one is going very straight. They are in straight line. So what I do, that I just choose this yellow dot, okay, and I add trend line. When I add a trend line, you see this is my linear line. Now this is the line, you know that where it is starting. If you say that this is the -10, it is going little below 12, 10 means around -11. So this is my value of C is, okay. 7 to 2 is a slope, I won't be able to explain, but this is the way it is sloping onto onto the y-axis, okay. And rest everything is straightforward. Now that I've got all that L coordinate and which is giving me that straight line, okay. Now this is the probably that through this formula it is probably would be the best line which has come, and it gives you a most accurate predictions. That's if you really see what would be the runs after 15 overs and 20 overs and all, and that's the way you draw the linear graph. So that in you can do that in Python and all, it would is much simpler because all this calculation you don't have to do that. There are the straight libraries and functions are there which do all this calculation in the background, and ultimately what would be doing that, using the Python code you would be getting this, you would be adding this additional uh, column into your data frame, which would be your value of linear lines pointers, and then above this your two original value one variables, one the dependent and independent one. And once you get that, then you can use that library plot graph functions and all, and which will let you create that linear chart and graph. Okay, so friends, I hope that has been very simple out there to you, and you understood that concept of linear regression and how it is calculated. I would be sharing this Excel sheet in this video link below. I'll be sharing the link in the caption of the video or somewhere down there in description. So you can download this same Excel. You can play around with that. Um,